Simply put, the more fuel we use, the more waste we produce, and conversely, the less fuel we use, the less waste we produce. The waste varies, but it's still waste. And that's why energy content matters. Our current low-sulfur IFO 380 contains an average of 41 megajoules per kilo, which equates to about 11 megawatt-hours per ton of fuel consumed. Our industry's focus on synthetic fuels made from green hydrogen contain less than half of that energy of bunker fuel. Green methanol contains just 20 megajoules per kilo, and green ammonia slightly less than that. Now, our industry's transition to this end of the energy spectrum would therefore result in more than 100% increase in our fuel consumption and with a corresponding increase in our waste and emissions footprint. And this is where new nuclear really comes into it. Nuclear fuel from uranium, which has been safely and efficiently used in power generation and nuclear navies since the 1950s, contains 80 million megajoules per kilo. That's equivalent of 22 million megawatt hours per ton of fuel. For an easy comparison, that's roughly 4 million times more energy per ton of fuel than the proposed alternatives. Now, physics tells us that the quantity of fuel and the fuel efficiency guide the quantity of waste that we produce. Unused carbon in exhaust from burning bunker fuel mixes with oxygen in the air and creates approximately 3.2 tons of CO2 per ton of bunkers consumed. And that's how our industry contributes its 2.5% of the 50 billion tons of global CO2 emissions every year. LNG and green methanol would improve on this, whilst in green ammonia, the pilot fuel required would be the only source of CO2. Now, with nuclear fuel, since we use so infinitely little of it, we produce a negligible amount of waste. And this waste, whilst toxic and harmful if ingested, is never released into the environment, like we do with exhaust gases. If it is not delivered or ingested, logically, it is not harmful to us.